Hello everyone, welcome to this tutorial on the PySpark SQL between function. In this video, we'll show you how to easily check if a column's values fall within a specific range using the between function. Whether you're working with numeric values, dates, or even alphanumeric data, between allows you to perform efficient filtering without writing complex conditions. We'll walk through examples to show you just how powerful and simple this function can be. Let's get started. Introduction to the between function. The between function in PySpark is a powerful tool used to check if a column's value falls within a specified range, similar to the between clause in SQL. With this function, you can define a lower and upper bound, and the between function returns true for any value that lies between these boundaries. This is particularly useful when you want to filter numeric columns, dates, or any other data type that follows a specific order. For example, when working with sales data, you might want to filter records where the sales figures fall within a certain range. Similarly, with date columns, you can use the between function to retrieve rows where the dates fall between two specific points in time. This function simplifies the process of applying range-based filters, making your data transformations more efficient and your code more readable. The between function allows you to work seamlessly with ordered data, giving you the ability to quickly narrow down your dataset based on predefined limits. This makes it a go-to function when handling data with natural boundaries such as numerical ranges or time periods, providing an intuitive and SQL-like approach to data filtering in PySpark. Basic syntax. The basic syntax for using the between function in PySpark is dataframe.filter column.between lower underscore bound, upper underscore bound. This syntax allows you to filter rows in a data frame where the values in a specific column fall within a defined range. The column parameter refers to the column whose values you want to check. The lower underscore bound defines the minimum value for the range, while the upper underscore bound defines the maximum value. When applied, the between function checks whether each value in the column lies between the specified lower and upper bounds, including the boundaries themselves. If a value falls within this range, the row is retained in the filtered data frame. This function is particularly useful for handling numeric data, such as filtering values that fall within a certain range of numbers, or for working with dates where you need to select data between specific time periods. Using the between function simplifies range-based filtering by allowing you to specify both bounds in one concise statement. Instead of writing complex logic with multiple conditions, the between function provides an efficient and readable way to handle range-based comparisons. This makes it a valuable tool for tasks like identifying data that falls within specific thresholds or working with ordered datasets. Why use between function? The between function in PySpark is highly beneficial because it simplifies the process of filtering data based on a range of values. Rather than writing out multiple conditions such as and to check if a value falls within a specific range, you can use between to achieve the same result with a more concise and readable approach. This function combines the lower and upper bounds into a single expression, reducing the complexity of the code and making it easier to understand. The simplicity of between makes it especially useful for filtering numeric values, dates, or any data types that follow a natural order. For example, instead of checking whether a number is greater than or equal to one value and less than or equal to another, you can simply specify both boundaries within the between function. This improves code clarity and helps to avoid errors that might occur when manually setting conditions. Practical examples. 1. Filtering rows based on a numeric range. In this example, we are using the between function in PySpark to filter rows based on the values in the sales column. The data frame DF contains two columns, product underscore name and sales, representing various products and their corresponding sales figures. Our goal is to filter the data frame and retain only the rows where the sales values fall within the range of 300 to 600 inclusive. To accomplish this, we apply the filter method along with the between function to the sales column. The between function checks whether the sales value for each row falls between the specified lower bound 300 and upper bound 600, including these boundary values. If the sales figure for a row is within this range, that row is kept in the filter diaphragm. When the result is displayed using the show method, we see that the rows for product is sales 500, product B sales 300, and product D sales 600 are retained as their sales values fall within the specified range. Product C with sales of 700 is excluded because its sales figure exceeds the upper bound of 600. This example illustrates how the between function simplifies range-based filtering, allowing you to efficiently filter rows by checking if a column's value falls between a lower and upper limit. By using between, you can make your filtering logic more concise and readable, especially when dealing with numeric values or ordered data like dates or time intervals. 2. Using between for date ranges. In this example, we are using the between function in PySpark to filter rows based on date values in the transaction underscore date column. The data frame df underscore dates contains two columns, transaction and transaction underscore date, representing different transactions and the dates on which they occurred. Our goal is to filter the data frame and retain only the rows where the transaction date falls between two specific dates, January 1, 2024 and September 30th, 2024. We achieve this by applying the filter method along with the between function using f.call transaction underscore date to reference the transaction underscore date column. The between function checks if the transaction date for each row lies between the specified lower bound 202400101 and upper bound 202400930. If the transaction date falls within this range, the row is retained in the filled data frame. When the result is displayed using the show method, we see that transaction which occurred on 202400101 and transaction B which occurred on 202400615 are included as their dates are within the specified range. However, transaction C which occurred on 202410001 is excluded because its transaction date exceeds the upper bound of 202400930. This example demonstrates how the between function can be applied to filter rows based on date ranges. By specifying a start and end date, you can easily filter data to focus on transactions or events that occurred within a particular time frame. This approach is especially useful when working with date or timestamp columns, allowing for concise and efficient range-based filtering. 3. Combining between with other filters. In this example, we are combining the between function with another condition to filter rows in a PySpark data frame based on two criteria, sales values and product names. The data frame DF contains two columns, product underscore name and sales, representing different products and their respective sales figures. Our goal is to filter the data frame to include only the rows where the sales values fall between 300 and 600 and the product underscore name starts with product A. We achieve this by using the filter method, combining the between function and the starts with function with the and operator. The between function is applied to the sales column, checking if the sales values are within the range of 300 to 600 inclusive. The starts with function is applied to the product underscore name column to check if the product name begins with product A. Both conditions must be true for a row to be retained in the filter data frame. The operator ensures that only rows meeting both criteria will be included. When we display the result using the show method, we see that only the row for product A with sales of 500 is returned. As it satisfies both conditions, its sales value is between 300 and 600, and its name starts with product A. This example illustrates how you can combine the between function with other conditions to perform more complex filtering operations. By using logical operators, like you can build flexible queries that filter data based on multiple criteria, making it easier to work with and analyze your dataset according to specific requirements. 4. Using between for conditional aggregations. In this example, we are using the between function in PySpark to filter rows within a specific sales range, and then we apply an aggregation to calculate the total sales for those products. The data frame df contains two columns, product underscore name and sales, representing various products and their sales figures. Our goal is to filter the data frame to include only the rows where the sales values fall between 300 and 600, and then calculate the sum of the sales for the filtered products. We begin by using the filter method along with the between function to limit the rows to those where the sales values are within the specified range. The between function checks if each product sales value falls between the lower bound of 300 and the upper bound of 600 inclusive. Only rows that meet this condition are kept. After filtering, we use the ig function to aggregate the filtered data. Specifically, we apply the sum function to the sales column to calculate the total sales of the products that fall within the defined range. The alias function is used to rename the resulting column as total underscore sales for clarity. When the result is displayed using the show method, it returns the total sum of the sales for all products within the sales range of 300 to 600. This approach demonstrates how you can combine filtering with aggregation in PySpark to gain insights from your data. By using the between function to narrow down the dataset and the ag function to compute aggregate values, you can efficiently perform both filtering and analysis in a single workflow. 5. Applying between to string values. In this example, we are using the between function in PySpark to filter rows based on alphanumeric product codes. The data frame df underscore codes contains two columns, product underscore name and product underscore code, representing various products and their corresponding codes. Our goal is to filter the data frame to include only the rows where the product underscore code values fall within the alphanumeric range from a 001 to B999. To achieve this, we apply the filter method along with the between function to the product underscore code column. The between function checks whether each product's code falls within the range defined by the lower bound as 001 and the upper bound B999. This alphanumeric range means that any product code starting with A or B and followed by a numeric sequence will be included as long as the code falls between a 001 and B999. When we display the result using the show method, the output includes the rows for product A with code as 001 and product B with code B002, as both product codes fall within the specified range. Product C with the code C003 is excluded because its code does not fall within the A001 to B999 range. This example demonstrates how the between function can be used to filter alphanumeric values in PySpark. It works seamlessly with both numerical and string data, making it a flexible tool for filtering columns that contain ordered data, such as product codes or identifiers. By defining both lower and upper bounds, you can easily filter data within a specific range, even when working with alphanumeric strings. 6. Handling null values with between. In this example, we are using the between function in PySpark to filter rows based on a sales range while handling null values. The data frame df underscore with underscore nulls contains two columns, product underscore name and sales, where some rows have missing null values in the sales column. Our goal is to filter the data frame and retain only the rows where the sales values fall between 300 and 600 while gracefully handling the null values. We apply the filter method along with the between function to the sales column. The between function checks whether each product's sales value lies within the specified range, which in this case is between 300 and 600. If a sales value falls within this range, the row is retained. However, the function does not consider null values, meaning that any row with a null value in the sales column will be automatically excluded from the filtered data frame, as the null value cannot be compared against the numeric range. When the result is displayed using the show method, the output includes the rows for product A with sales of 500 and product C with sales of 600, as both fall within the specified range. Product B, which has a null value in the sales column, is excluded because null values are not included in the range check. This example highlights how the between function in PySpark automatically excludes null values during range-based filtering. By using between, you can efficiently filter data within specific numeric ranges, while any missing or null values are handled seamlessly, ensuring that your data transformations remain robust even when dealing with incomplete datasets. That's it for today's tutorial on the PySpark between function. As you've seen, this function provides a straightforward way to filter data by checking if values are within a defined range, all while keeping your code clean and efficient. Whether you're handling numbers, dates, or strings, between is a versatile tool in your PySpark toolkit. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell for more PySpark tutorials. Thanks for watching and see you in the next video.